This is microwave power meter MPM12. Switch on the instrument by connecting the SMPS from the back panel. Now the TFT display shows warming up and asks the user to wait for 1 minute. Till that time, sensor should not be connected to any microwave source, gun, klystron or DRO. It displays disconnect sensor from microwave source because it will search the lowest power as noise floor, which is minus 30 dBm. So it asks user not to connect sensor to any source and keep it idle. Now as you can see, we have connected a gun oscillator in a microwave bench setup, and we will try to measure the attenuation of variable attenuator and coupling factor of directional coupler. Now the TFT display reads band as X band because it's a WR90 waveguide sensor measuring from 8.2 GHz to 12.4 GHz. It shows power meter low. Low means the noise floor is minus 30 dBm because no microwave output has been connected to the sensor. Now we'll connect the sensor at the port of directional coupler. Now we'll tighten the screw. Now the gun oscillator micrometer can also be tuned, and we can see the variation of power of gun oscillator with the help of this power meter. Now as you can see, the power meter is displaying around minus 4.5 dBm, and when we tune the micrometer of variable attenuator, we will see that attenuation will occur. Right now it is reading minus 4.5, now it is reading minus 5.2. So as you can see, the resolution, minimum resolution of power meter is 0.1 dBm. We are still tuning the micrometer, and you can plot the power variation of variable attenuator with the help of this power meter. Now this power can also be changed to different units. Now as you can see, it is showing 23 different units. The most commonly used are dBm and milliwatts. If we select power unit as milliwatt, you will see that the sensor is reading 0.047 milliwatts or around 47 microwatts. Similarly, there are three different ways to measure power: average, peak detect or RMS. We will normally use average mode. We will again select dBm. Now it is showing minus 13.3 dBm. We will again take out the plunger of micrometer. Now as you can see, it is reading at the port of directional coupler, it is reading minus 4.1 dBm. Now we'll measure at the coupled port and we'll try to find out the coupling factor of the power meter. Always ensure to tighten all the 4 screws of the sensor so that there is no variation of power during measurement. Now the earlier reading was minus 4.1 dBm, and with the termination connected at the open port, the power is minus 16.7 dBm. So the difference of minus 16.7 and minus 4.1 is the coupling factor of this coupler, and this has been measured with the help of X band power meter MPM12.